can start this session.
Okay, sir. So, good afternoon, ladies and gentlemen. I am Aniket, and I will be your host for today's webinar. First of all, I would like to thank each and everyone for taking out their time and joining the webinar, Redefining Riding Experience with RAMSIS. I would like to introduce Mr. Raghu Prasad, sir. He heads the marketing department at EDS Technologies, and he holds an overall experience of 20 years. So I would like to ask Raghu, sir, to please give a short brief about EDS Technologies corporate profiles.
Thanks, Aniket. Good afternoon, everyone. And I once again welcome you all to this webinar. This, as you know, is specifically on ergonomics in two-wheeler design applications. So we are excited to have all of you with us today as we explore the importance of ergonomics in two-wheeler design and how RAMSIS is changing the way we approach ergonomics specific for the Indian demography. To start, I would like to give a brief overview of EDS Technologies, who we are and what do we do. I'm sure most of them should know us, but then for the benefit of all, we are a 30-year-old organization, a leading provider of cutting-edge engineering and technology solutions in India. We partnered with some of the world's most innovative companies in order to bring advanced technologies to Indian markets. This in turn enables our customers to enhance their product development, design, engineering, and manufacturing processes. We have served more than 2,000 customers till date, and these would cut across the different industry segments like automotive, aerospace, industry equipments, etc. The wide range of solutions from our area would include, virtual twins, where we partner with Dassault Systems for product design, engineering, and manufacturing software applications. We also have signed up with EOS for 3D printing for metal and polymer systems, with Synopsys for EDA verifications and IP solutions, as well as for optical solutions for automotive lightings. We also have, solutions in the area of geospatial intelligence, where we are signed up with S3. So I would like to give a spotlight on our relationship with Human Solutions. Currently, it's called as Humanities. We have a long-term relationship with them, and the idea of having a collaboration with Humanities is to provide end-to-end, offerings to our customer base in the automotive segment. And as you know, RAMSIS is a leading application used worldwide by almost all leading automotive players worldwide to ensure that the vehicle designs are suited to the demography they cater to. It also allows to ensure the digital prototyping with respect to ergonomics is done very early in the product lifecycle. And I'd like to point out one of the early associations that we had, in India. It was with ARAI. It was for the Size India project, and this helped, for ARAI to create India-wide demographic data, which later, all the OEMs across are using it. And after this, many OEMs have started using RAMSIS, and the list is still growing. Today, as you know, the importance of this webinar is how the consumers look at, buying their vehicles, or what they look at, from their ownership of the vehicle is sort of different. It's changed. So, and ergonomics plays a major role in that. So, to speak about this and others, we have a light panelist that we have, and we have one of the eminent speakers from our customers, TVS Motors. So we are glad to have the team here. So we have the guest speaker, Ms. Manasa Corrada. So she works in the ergonomics department for TVS, and her work is in integrating ergonomics into vehicle design, conducting riding posture evaluations, and virtually calibrating perceived comfort specifically focus on seat comfort and roominess. And from ADS Technologies end, we have guest speaker Sushil Punaskar, who is a senior solution consultant with us, and he works in very specialized areas, working closely with the customers on applications such as RAMSIS, Q Checker, Kava solution, etc. He has more than 20 years of industry experience working with leading Indian OEMs as well as European OEMs. And in addition to ergonomics, he also specializes in BIW design and development, composites, and carbon fiber body in white design. So this is an overview of the webinar that we are planning today right now. And as you would listen to our speakers, we'd like to inform you that we'll be taking up Q&A after the delivery of the webinar. But you can post the questions, as the session goes on. That can be done through the question box, which you can see in your panel. After which, we will take out these questions towards the end of the session. So now I would invite Ms. Manasa to take over. Thank you.
Hello. Good afternoon, everyone. I'm Manasa. I am, as Mr. Raghu Prasad has introduced me, TVS Motors for the past 4.5 years. And I started working as a designer 2 years, and then I started in this role for the past few years. So I would like to mention myself as I took the entire responsibility of the simulation engineering in TVS Motors with the help of RAMSIS software. Okay, can you go to the next slide, please? Can broadly classify a posture segmentation into two categories. One I would say is the scooter way, and one I would say is the motorbike way. I would like to say that most of the Indian customers would prefer using scooter for a daily commute rides and city rides, which could require for a shorter distance, and thereby a very comfortable posture is required for day-to-day use. And whereas on the motorbike segment, as you can see on the next slide, this is preferred for a longer durations or highway journeys or for a trip or touring purposes. Both of them have significant domain in this market as of now.
Ms. Manasa, can you be a little louder?
Okay. Am I audible now?
Yeah, you're audible. Yes.
Okay. So I would like to say that these are the two major dominant profiles of two-wheeler segment right now in the Indian market. I would like you to go to the next slide. So I wanted to mention about one of the most successful TVSM product, which is right now released last year. So this is about Apache RDR 310, which is running right now in the market. So what we do, how we even decide the posture virtually is the most critical task for any NPD or a vehicle development segment. Basically, one has to understand the market where our competitive product lies, what we are trying to achieve in VSL as a product to the customer. So we usually understand the target segment first. What is their niche? What is the liking to the market? And what could be the most attractive feature that as TVS we can give to the market or to the customers? So I would like to mention poster benchmarking is one of the most significant important segment over here, which we use RAMSIS to understand how a typical anthropometric Indian anthropometry could use the vehicle in their own segment or in their own activity. So as you can see, we have benchmarked 4 vehicles along with RTL 310 to understand where our posture could lie in a most target customer oriented way. What could be the comparison against all other benchmarks and what as TVS is offering? Like we have to understand where the most comfortable points as the pillion are in a vehicle so that he can actually ride without any discomfort. Can you go to the next slide, please? Using RAMSIS, we take the motorbike neutral posture into picture and then simulate the most possible posture, as you can see over here. And then we actually make sure that each and every touch points, as well as on the handlebar, on the foot pegs, on the seat, on the fuel tank covers, have been touched on properly so that rider will have minimal discomfort while riding the vehicle. And we make sure that with minimal iterations and using the software, we would be able to reach the vehicle at a very good stage. And yes, so this could be the most generic procedure, I would say, for any posture simulation that we follow. Can you go to the next one, please? Yes. So apart from the normal neutral sitting postures that a rider can usually perceive, there are even other certain interactions when he or she is trying to use the vehicle are trying to be captured through RAMSIS so that a discomfort by using the vehicle can be avoided in a very virtual stage. Here are some, I would say, some examples where the interaction with the passengers as well as vehicle is important. I would say opinion egress egress along with the interaction of rider is crucial for the current market trends because of the use of pannier boxes, the increasing need of going on a long touring rides, and the ease of accessing each and every touch point as in a seat lock accessibility. We are able to use RAMSIS in these situations to understand how the rider as well as the pillion interacts with the vehicle so that a minimal redesign can be done in physical stages of the vehicle. As you can see in the extreme right side, we even make sure that the rider and the pillion have a comfortable seating posture virtually using RAMSIS. On an overall scale, I would say that using virtual simulation softwares, we are able to perceive a very close reality to what we can achieve in the vehicle in physical stages, but at a very, very primitive stage. This can help us and giving us very fast iterations along with an efficient design. We can actually go for a reduced number of prototypes instead of relying on each and every part for the prototype for the part of the vehicle to come by. And consequently, the cost and the time would be saved. I would like to say this is how TVS is trying to use RAMSIS for ergonomic simulations. Over to you, Sushil.
Yeah, thank you, Mansa, for your time and very good presentation here, how RAMSIS is benefiting TVS Motors. So from here onwards, we will start our technical presentation, the main content of this presentation today, webinar today. So these are a list of content that we go through, like we'll start with RAMSIS for automotive in general, how RAMSIS is used in two-wheeler industry. Then we will see some typical analysis in RAMSIS, ergonomic analysis like direct vision, reachabilities, mirror vision, force analysis. It will be followed by RAMSIS application demonstration from our side, and it will be lastly followed by Q&A session from the whoever joined this webinar. So yes, we'll start up front here. So we will just see how RAMSIS evolved and what is the history behind it. So if I just make my pointer on here. So up until 1960 and very primitive days when there were two-dimensional scenarios, drawings, and etc. Mainly it was the ergonomics of the vehicles was taken care by mostly the SAE standards. But the SAE standards were like they were important, definitely. They gave some guidelines for ergonomic assessments, but they were in 2D, two-dimensional. Mostly they were based on American data, USA data from 1960, and they are same from everyone. But we know that anthropometry changes continent by continent, nation by nation. And around 1990 and early 2000, we with the advent of a lot of new three-dimensional CAD applications like Ideas, CATIA, NX, and Creo, there was a need felt globally around the community to have ergonomics also done in the three-dimensional way. And thereby we had RAMSIS evolved in that way. And whatever ergonomic quality of the cars started drastically improving after that with the advent of RAMSIS after 1990 or after 2000 year. So it is definitely benefiting the overall ergonomic quality of the cars. So what is RAMSIS basically? So RAMSIS is, if we start to abbreviate RAMSIS, it's a realistic anthropometric mathematical system of interior comfort simulation. That's what RAMSIS is abbreviated with. It's the most comprehensive ergonomic simulation software in the design of vehicles and aircraft. It has a realistic representation of the human beings, which is available very early in the development process. So you did not wait for the physical prototyping, wait for that. So it can shorten your development cycles. It can save a lot of development cost and efforts. And it can provide you early evaluation of bike and driver appearances. And it can also increase your product quality and overall customer satisfaction. And it's a leading ergonomic simulation software worldwide used by more than 70% OEMs globally. So who is the customer? Who is supposed to use our cars and two-wheelers and scooters? So we in RAMSIS we have documented international databases of mostly all continents and all nations, starting from Germany. We in India we have ARI size India, China, America, North America, South America, Korea, Japan, and Mexico. Age groups wise, we have 18 to 70 age group, 18 to 30, male, female, child are also covered in it. In India, we have up to 2040 Indian data anthropometric databases available to choose from for your future car programs or bike programs. RAMSIS also provides secular growth where there's a database progression facility available. So you can choose any future database for your future cars and programs. Then apart from that, apart from this available databases, we can also have custom made body sizes and body proportions with which we can achieve with the help of RAMSIS Body Builder module, which is available in RAMSIS. RAMSIS mannequins are realistical appearance and they have a credible appearance. They are scanned to very high accuracies with the realistic populations. So you can choose as many, apart from the driver and the databases, you can choose out of them how many drivers you want to declare and study them in your vehicle context and how many pillions and riders you want to study. So you can choose literally choose as many as you want and make the vehicle geometries and controls suitable to those many selected driver populations. So RAMSIS Body Builder, we can literally update and modify the dimensions we want according to our needs. And it is a typical example where the green arrows suggest what dimensions can be modified out of RAMSIS mannequins. So it's called modify selected measurement. So we can select the body height here, and we can change the body height and proportionately with the algorithm built inside, it changes the proportions of the mannequin accordingly. You can choose out of this head height, head width also, and you can make custom built mannequins, which you can later make use for the ergonomic assessments in your RAMSIS software. So just like in car context, we package the equipment in the very first layouting and architecture designs, architecture studies. Similarly, we have in bikes something called ergonomic triangle, which comprise of the seating position, a primary position, then the control position, the footrest position, and the handlebar position. This triangle constitute the ergonomic triangle, which tells mostly everything about the riding posture, whether it is a cruiser bike, it is a scooter, or it's a sports bike. So first we have to start with define the markets, choose the anthropometric databases correctly, and choose the posture models. So for defining the target, we have, as I said in the last couple of slides, we have all continents and all demographies data is available built inside. We have different age groups. We have reference years, reference progressions also. We can choose from the size, corpulence, adjustments, and proportions. Apart from that, we have this RAMSIS posture model, which is like a distinguishing feature of RAMSIS, which can provide you a very ready to use posture models for different industries, for bike and cars also. So just a glimpse of that is these two posture models highlighted cater to the bike two-wheeler industry, motorbike all-rounder, and motor scooter. Apart from that, we have car posture models exclusively for passenger car industry. F1 car posture models are readily available. Trucks and aircrafts is also available. Yeah, so one of the most distinguishing feature of RAMSIS application is its automatic posturing capability. When we call upon or add any mannequin in RAMSIS environment, we get a tall standing, a default posture mannequin. If you look at the left side of the picture, and with the help of geometry constraining and task assignments, we can make the mannequin take the most comfortable position in the seated position. So if I just play the video here, you can see the mannequin assuming and self-posturing inside the vehicle geometry. So that is possible with RAMSIS. Otherwise, it takes hours and hours and days to posture and position it correctly inside the vehicle geometry. We'll see the reachability, like the controls should be in the reachable position. For example, the thumb controls here. So we should always know what is the minimum. The shortest female should be able to reach the controls here, and not just the taller people. So we can position the control by knowing this thumb envelopes geometrically. Then we have finger controls, finger reachabilities, all the fingers reachabilities we can know. And we can then choose how we position the controls accordingly in the most comfortable way. And we also have, there is also RAMSIS motorbike library that we will see in later slides. You can also use that to position it correctly, your controls in having those geometries applied to it. You can do direct vision analysis also on the forward direction. So the mannequin typically here is looking at the instrument cluster here, and he is able to see this view. What RAMSIS benefits is that to have this view known to us, we technically need one prototyping done here. And without that, we can't really have this assessments done. So RAMSIS provides you a very advanced capability of simulating these visions for the driver. So you can literally check the ground visibilities, visibility of controls, as you see here, and visibility of the instrument clusters, dials, and displays. RAMSIS also provides you a joint capacity where you can you can do assessments about the postures and discomforts, as we marked here. And you can judge what are the angles and what position is really awkward and uncomfortable for the riders. And then it gives a color graph like which angles of the mannequin are going out of the way and they are not comfortable to it, so that you can make proper judgments and make some design solutions to resolve those awkward positions. Mirror indirect visibility is also one of the part of RAMSIS. It gives you that facility as well. So here the mannequin with the helmet on, a typical scenario in the city riding, is looking at the rear view mirror, in the right rear view mirror. He's able to see this view of the traffic inside the mirror here, what you can see here. And this is the mirror cones that the smallest woman is able to see. So these are the typical cones that can be exported out of RAMSIS and taken to the native CAD applications and for the assessments. Not only the smallest woman, but the all the population inside the seated position. Three people's now mannequins now. So all this can be taken out, and you can see what is the rear view vision for all these three populated mannequins. Force analysis is a very distinguishing feature of RAMSIS, which gives a very good idea right in the digital phase itself to understand in the seated position how much of force the mannequin can generate in the seated position at different body locations and body geometries. For example, this is a typical scenario where he's trying to press the clutch or the gear shift lever, and with the ball of foot here. So here's the ball joint of the foot, so it's called ball of foot. At this location, how much force he can generate, uh, that force value can be known upfront in the software. And that is a very good value to know very early in the design, so that if the force values are too high or too low, we can make design corrections in our controls design, or maybe in the clutch geometry, or maybe we can increase the leverages by thereby reducing the forces. That all assessments we can do quite easily here. So it gives a 3 level of forces, like maximum force, which the mannequin just sometime he does it like pressing the kick lever, which we don't really use now, but that is a one-time activity. So it needs maximum force. So that also force it can give you. Tolerable force is something that he intermittent actions or controls he operate in the seated position, that much how much force will be required for that operation. So that tolerable amount of force also it can be known. And permanent force is something like holding this handlebar or holding the steering wheel. So handle and steering wheel is also one of the important controls. So for holding them, how much force will be needed, because we hold the steering wheel and handles all the time. So that much so we have to estimate, or we should know what force is really required for that. So even that force is available to know from here. So from this, you can really know this force values also. From the seat to one of the mannequin is made to sit on the location. He has occupied the position. He has occupied himself in the seating geometry here, and then we can really literally extract his contour out of the body contour, and then further make use. So I will just show you. So this is a typical contour of the mannequin, seated mannequin, that can be exported out of the RAMSIS. So if we just see that this is the typical contour. Now, if we can export this contour out of RAMSIS, we can place in our native CAD applications, and we can study how far it has an intrusion with the seat, and is it going too close to the beneath metal geometries and pipings and tubing, etc. That also can be known, or many other assessments can be done out of it. If any OEM decides to provide a different type of stiffness at the rear and the front, even those can be decided with deciding the length of the uh, less stiff area and the more stiff area. That also can be one of the study that can be done with the help of this contact contour. And its geometrical output is can be derived, so that's a good part of it. Ground reachability is another tedious topic in, especially in the biking industry, where the saddle height is of really great importance. Whether it tells a lot of things about whether the shortest person can reach the ground comfortably or not. This is especially very crucial due to the reason that in traffic scenarios in city tight conditions, we have to have this quite really ensured, because a too high saddle position will really make the short person uncomfortable to properly maneuver the vehicle. So as you see, the tall male, the 95% male is comfortably reaching the ground here. The medium male, 50 percentile male Indian male population, with the toe or the front, he can slightly reach the ground, but he's not that unhappy or happy, both. But the shortest male or female is finding it troublesome to reach the ground properly. So he's just standing on his one support. But this is a uncomfortable position to uh, uh, is as such. Yeah. So we can study these scenarios in RAMSIS. Otherwise, for this reason, we need the actual human test populations of those sizes, and then we can have those studies quite late in the program when we have actual prototypes done. And there is no chance of any, or very less chance of any rectifications or design rectifications, due to the reason that by that time, a lot of prototyping and soft tooling and tool ordering has been started. So any changes takes a lot of cost, time, and efforts. Yeah, how RAMSIS can benefit you for the product design? We can also, it can also give you some hints about how we can improve our design conditions. That also we can see. So the color graph here is not really any stress condition, like a stress features or stress values, but it represents three type of mannequins here, just colored with different colors here for the sake of understanding. But with these three population, you can place them in the seated position, and you can study the vehicle interfaces that are having direct contact with the body dimensions or body proportions. So any physical contact with the vehicle geometry is actually a kind of a vibration path towards the mannequin. Thereby, the mechanical vibrations travels to the mannequin, and it makes them irritable and discomfortable, so that he can't drive for a longer time. Yeah. So such contact should be very early known to the ergonomics engineer, so that the vehicle geometries can be properly optimized, and such unwanted scenarios shall not come very late in the vehicle launch programs. Another scenario is like the transmission casing. This can't be known unless we position the digital mannequins or the physical mannequins. But it gives a good chance in the digital way that we can know the such interferences, which may otherwise again hard contact between the vehicle geometry and the human. And then we can the design condition here will be to just give some kind of design changes here, or shifting the position or something here. Those judgments and decisions can be very confidently made out of these studies. Another good topic is that we in biking industry, we always ride with our different add-ons and clothes and apparels, what we usually do, trousers, etc. So RAMSIS provide the possibility to have those add-ons on top of the mannequins, the digital mannequins, and study the scenarios, or study those different activities with the help with those add-ons on the mannequin. So, for example, the first mannequin I have chosen is has wearing some jacket here, so street wear here, and with the boots and trousers here. But and then I will make some certain studies. But if I have to make another kind of add-on here, like a textile suit and toe rings and gloves here. So with just of a click of a button, I can change the mannequin to the desired apparels. So this is quite done in a very click of a button. And then the mannequins take those apparels and add-ons, and then we can do our studies accordingly. I think this is where we start, like the first, this also we saw in the very first slide. So the ergonomics triangle really defines your, whether it's what kind of posture it is, whether it is a cruiser bike or it's a scooter or it's a sports bike. So this triangle tells you quite a lot, and this is where the architecture studies of the two-wheeler starts with. And then we can do a lot of with the RAMSIS, we can do these studies quite early. That in the even in the sports mode, uh, what will we have? What will happen if I just try to make it slightly the clutch or the footrest position slightly forward, slightly backward, or slightly up or slightly down? What will be the delta effect of all these changes? We can study right in the RAMSIS by knowing the joint capacity, what we saw in the previous slides, and choose the most optimum ergonomic triangle for our use that will be eventually comfortable for those test population. For example, the Indian mannequins or Indian population. So this is very crucial in the studies, because here we saw a lot of problems where there is some concerns that either the footrest is quite low or quite high, or the steering has, or the handle position is quite forward or quite backward or quite high in the position. So, and this give a lot of stress on the mannequin, because the mannequin is all the time in the scooter or the bike posture. The mannequin is always on the kind of high spinal column loads. He's always loaded with the high stresses on his spinal column. So we can avoid that by choosing the right optimum ergonomic triangle. I think with that, that was possibly the last slide from my side. I think we have one more, yeah. So the condition here is that the footrest here, we can try different iterations, like this is slightly inboard, this is slightly outboard, and we can study both the conditions and see how the posture is making comfortable at this position. So these all delta studies can be, this is a typical ergonomic study that we can do. Again, the force analysis, what I see here, you can generally, you can readily see the force values, what can be typically applied at the ball of foot level here. So these give ready-made force values that the mannequin can exert at this point of location. I think that was it. With me is Satyam Pandey, who will demonstrate the application, RAMSIS application, and he will take you to the application UI and etc. And he will demo some cases for you. So over to you, Satyam. Thank you.
Yeah, hello. I hope my screen is visible.
Yeah.
Yeah. So I'll just quickly go to the applications. So this is we have the annex. We have the RAMSIS next gen in standalone. So for example, we have one here 2D, two-wheeler geometry of the bike, and here this is the typical UI of the RAMSIS next gen looks like. So in the start we have a different aspect like ergonomics and project managers and bodybuilders, where we do a different analysis. So how to iterate this, how to create the mannequin, how to iterate the process, that is what I'm going to showcase you in these small demonstrations. So first, if somebody wants to create the populations or test sample filters, so we have something called the project managers, where we go into the project manager and define with the role definitions, and where we define the naming, for example, the rider or pillions, for example. And then we define the range of motions, basically the different range of motions leads to the different the movements of the body. And then we have the edge points, like we have a different edge points. Typically we use select the average edge points, where we select as a mannequin neutral postures, where select as its average sitting positions. and then we have a different adjustments. Yeah, we have the age dependence visions. If you are creating the in the slide you have seen that we have the age groups. So if you are creating the age group or you are creating the old mannequin, so you can change into the dependence visions where you will give the more realistic scenario where the mannequin, how the mannequin visual is getting affected, yeah, with respect to the age. And the posture models we have here, like we have the, for the bike we have the motorbike all rounders, and we have something called motor scooter models. Yeah, so this motor this namely we select in order to validate the ergonomic studies for the for the mannequin or for the rider or for the pillions. Yeah, and then we select the pre-positioning points in order to do the simulations from where, like, for example, the prepositioning point would be your edge points. So you have to define your edge points, or maybe sometime your edge point could be a G hip center or GSZs. So that point you can define it in, and then you can create. On the click on that create, and then it will be created. So for example, you can see here the role definitions. I have here one for pillion and one for riders. Named you have created, and then if once you created the role definitions, so in that, after creating the role definitions, basically you can create the mannequin. So in the role definitions, basically you are defining for what you are exactly going to create. For example, whether you are creating for the riders, whether you are creating for the pillions. So you can see here we have both rider and pillions. And then here, for example, if I want to create the mannequin, for example, if I want to create a small mannequin, medium mannequin, either I can go for the the sizes which are available here. Yeah, you can see the populations, you can see the age groups. I can select any of these, and the nation data, which nation data I have to select it. So for India, we have India and India ARAI size India, two data. And nonetheless, we can also select the gender, which gender you have to want to select, male, female, or child, if you want to perform those studies. And top of that, you can also select the body measurements. Now suppose you have created any mannequins or some part, you have taken some actual mannequin person data, and then you can import inside the RAMSIS by using the PML. Yeah, and then you can click on a create. The mannequin will be created. For example, I'll just do one thing, I'll create one mannequin instantly, so I can just show you how exactly look like here. I'll create one tall male. So basically, your short male will be a 5th percentile, medium male will be a 50 percentile, and tall male will be a 95th percentile. Yeah. So I'll just create one tall male. So, male. I select the referral years, for example, 2024. I'll select, and I'll just create tall male. So you can see this mannequin has been created here. Yeah, so along with the textures, along with the shoes. Yeah, now what we have to add, the we have to definitely add the constraint. So before we add the constraint, we have something called skin point here. So you can see some of the skin point here added already here. And if you want, you can create the skin point on the anywhere on the body which are been available in order to perform some any kind of study. So and then once you created the skin points, then we have something called ergonomics here, and inside that we have operations. Inside the operations we have something called definition restrictions. So once you go to the definition restrictions, you are start defining the restriction with respect to the environment object and with the mannequin components, that is the points. So for example, if I showcase you here, so just I can select the mannequin edge points or GSN points, and then I can I can place inside on the seat. For example, here I'll selected the point which I've already selected for the 10, which I've created here, and then what I can do, I can simply just click uh, create, and these restriction will be created for mannequin. So you can see here the restriction has been created, and if I want to see these restrictions, or if not I want to see the restrictions, I can see in the restrictions overview. So you can also see this mapping has been created. If I You can see this red points is coming from the edge point to the seating points, and then simply I can just want to check whether the sitting point are correct or not, how the good sitting points are there. So I can just simply run the posture calculations, so I can be able to make it sit. So for example, and then maybe I can define the rest of the point. For example, handle points, handle points, and uh, the the points on the points on the foot legs and foot pegs. So those points also I can define it here, uh, and then I can simply run the posture calculation. Yeah, and so for example here I just make my mannequin sit on the edge points, so I can see I feel like my edge points are now here, the how the touching is happening, how the interaction is going on. And then I can also create the edge points on the on, for example, on the palm. In order to create those points, we have another, we have something called mannequin, and we in the mannequin we have something called skin points. So these are the inactive skin points. For example, if I click one of the points, yeah, and this is an inactive status, then I can give this point as the left grasping, let's grasping, and I can change the activity into the active stage, and I can set the individual naming also, and then I can close this. Now I can see the point is get activated. So once the points get activated, you can save them either way. uh, like we have some saving extensions, something called save as, and we have something called here BPT, that is mannequin body points, and you can save of the any naming of the any naming which you would like to give. For example, rider body points, rider male body points, rider male body points. If I want to give, I can save this, and then once I created all the points, and I can recall it. So I'll just recall the point which I have created for my session, for example. So I have something called open, and then I'll go into the skin point and I'll upload it. So now once I open it, it is asking me there is one already points are there. You want to merge it or replace it? So no, I want to replace with the new point, the point which I have created. Yeah, and then you see this points has been already been added in the on my skin points. The skin points is updated, and then similarly you can save this as a task file. So like for example, whatever the task you are defining on the operations, for the whatever the operations you are defining here, yeah, for the mannequins, what are the tasks, whatever the tasks you are defining on the operations, you can see I've just only given the edge points. So likewise you can define all the tasks here for a different different subgroups. For example, surface fixations, and the types of grasping you want to make. So those are the constraint you can add it here, and then you can save it as the something called task file. So I'll just quickly show you. Yeah, just a moment. So once you save that file, and then you can recall it, and then you can just simply run the iterations for all the mannequin at once, single go. So you don't have to place each and every mannequin individually. Yeah. So just here, like I saved the skin points. Similarly, I have something called the mannequin task. So here you can see this task is there. Similarly, if I go back, I can see my writer task here, and I can just simply open it, and then I can simply start the running this mannequin. So you can see all this points is getting is not accomplished when I run this restrictions. Now it's get accomplished, and now it's sitting is the best optimized positions for himself. Yeah, so this is how you can simply click of a button, you can run the all the analysis, and then you can see here the distance. If any of the distance is not zero, which means the restriction is getting, the mannequin is getting failed to complete that. So what changes you can make, then you can see your grasping, how how the grasping are there. For example, if you want to edit the grasping, you can click on the edit restrictions, and you can, instead of clicking on a grasp formally, we have the library called grasp formally also. So instead of softly, you can add that firmly. Later on, you can create your own posture and you can save it as a post file for each and every individual scenario. Yeah. Then for example, after that we have seen the mirror studies. So for example, my driver is looking more over it on the road view. If I want to make any movement with respect to my mirror view analysis or any kind of analysis, what I can do, I can simply go to the operations and we have something called move eye, and in a single up button I can just click select the points on the center, and then I can just simply uh, check this box on and I can set to the posture. So you can see now the mannequin is looking on the mirror, but you can see it can face issue if I turn on the ergonomic view where it says the limit the eye restrictions. But nonetheless, I want to make my head movements also. So you can see now the head is also moving and looking towards the the right mirror. Yeah. So we have something called more called mirror definition, camera definition. So if there is mirror you want to create, we have something called free forms. If you have the type of mirror, rectangle, planar, spherical, and if it's different, you can select as a free form. You can select the directions. You can select the object of the rotations, and then you can add the values here. For example, I've already created, so simply jump into the mirror view, how exactly the mirror view look like. We have something called analysis. So in the analysis, yeah, we have something called the right mirror. So you can see this is the pyramid which is formed, and what are the depth we want to make, like 4000 mm, 5000 mm, and then we can see this mirror. We can rotate the mirror to and then we can adjust the mirror as per our requirements. Yeah. So whatever the we want to keep on the optimal angle, we can also create, and then we can also adjust to create to set on optimal angle, and then we can create as a mannequin geometry if we want to see the visions. If we have the limit of 400 4000 mm of depth, if we have more than that, for example 5000 mm of depth, we want to use like, if we have the depth of 5000 mm, so whether the mirror is covering that area or not. So these are the property definitely are more or less if you will be receiving from your team to analyze these factors for the mannequin, and how the how this reflection is happening inside the mirror. For example, if I'm turning on my, for example, if I'm turning on my mannequin, uh, for for example, if I turn this off here, and I turn off my couple of the turn off the my couple of the traffic scenario, for example. So yeah. So so you can see here some of the traffic scenario, and then I can do again, I can go into the visions and I can see the cones, whether the cones are covering this area or not. So you can see some of the cone, it's if I create as a cone, if I extend this to 6000 and then create as a cone, so you can see like some of the area I've been covering on the mannequin on the mirror. So how well I can optimize. Also I can take this reflection inside the mirror as well. So this is one of the example of the mirror analysis. Yeah, and then we want to check how the how well is the posture has been optimized. Yeah, for example, in order to check those things, we have something called joint capacity analysis to do that. So yeah, so I'll go into the joint capacity analysis simply here, and then I can see here the discomfortment and posture I want to do for the postures, and we have the body regions for like legs, spine, arms, left hand, right hand, or the whole body. So I can either choose the individual or I can select the whole. You can see here so if whatever the green zone, you can see this is the best optimized positions, this is the good postures. The yellow one is acceptable because there are some degree of freedoms are mentioned presence for your joints, but the red zone you can see it's not acceptable. You have to optimize your the hip right left joints. So certainly, definitely, you have to optimize those things in order to give better degree of freedom and the good posture for your mannequin. Yeah. So with this, I think our demonstration has been complete for the mannequin. Yeah. Also, we can add the different aspects. For example, like different mannequin behavior which I have created here. I can just activate them to check how, if my mannequin is putting helmet, so how this scenario is look like for her. For example, yeah. So, so that also you can see here. Yeah, and also you can check the mannequin visions with respect to the helmet, without helmet. For example, if I have a different mannequin, medium mannequin, I want to see his what he is seeing on his focus area. So we have something called internal view, and then you can see this is what he is able to see. Like I can see the cycloplane eye, the combine of the both eye, and then you can see the left and the right positions of the angles, how exactly it is able to be. Yeah. So I think we have some time constraints, but yeah, nonetheless, we have completed this the demonstrations. So now we'll move to the Q&A sessions. Yeah.
Thank you, Satyam, for this very detailed demonstration. Quite interesting. So we can start. We would like to have some questions from the audience. Any typical question that you would like to know in more detail, or any general question, you can raise this question and we will be happy to answer them. Yeah.
Also, hello panelists. So I would request you to please switch on your cameras and mics so that we can ask the questions. So yes, we have got one question. So the first question is, what all types of anthropometric databases are available? So anyone from panelists could answer.
Yeah, good question. I will say it was right in my first slides, couple of slides. Like we have almost all demographies and continents and nations are covered, like North America, South America, Mexico, Europe, Germany, Italy data is there. India, for India, we have in India, we have this Size India, ARI Size India database, which is valid from 2010 to 2040. Then we have Japan, Korea, China databases are available. Yeah. So in all, all the nations are covered except Africa. Everything is covered in RAMSIS databases. Yeah. We have to choose your which continent you want to launch the vehicle. Take those specific respective anthropometric databases and start your assessments accordingly. Yeah.
Okay, thank you, Sushil sir. So the next question is for Manasa. So Manasa, how much time you could save in the design stage? If you could explain it in percentage of cost saved using RAMSIS software.
With the software, we were able to achieve 3 4 months of significant time for developing the RPD parts on vehicle level. I would like to say that for an NPD project, when you're developing a vehicle from scratch, it would be about 25 to 30% of time.
Okay, sure. Thank you. So, so we have one more question. Anyone from the panel can answer. So, the question is there any specific, is there any India-specific anthropometric data available for ergonomic studies?
Yes, there are two data is available. We have the India data, we have the ARA India data. So this data is, like in the presentation has been explained by Sushil sir, that this data is valid until for 2040.
Yeah.
Okay,
So
sure. Thank you.
ARI Size India database is
Yeah,
available.
and
So
how they are scanning this data? The ARAI have the body scanners, which are the evaluation ones, which is one of the most accurate body scanners. So they are individually going each and every cities, each and every state, each and every demographical regions of India, and they are scanning 4 to 5 thousands of people at a particular place. That is how they are generating into the RAMSIS those data. Yeah.
Okay. Our next question is, in general, how do we measure slash identify the SGRP in motorcycle seats and moped scooter seats?
Okay. So if somebody doesn't have the H point design, SGRP design, there is no SGRP design for a particular geometry or new proto who they are building. We have something called posture variations. So what it does is basically you can make mannequin sit over there manually. Just giving simple point, and then you can create the task something called posture variations, and then you can copy that posture variation to the CAD chart data, and then you can this posture variation is basically is a predictions for each particular mannequin how much he or she can travel with respect to the path along with the percentile. So that is how you can add it into the design iterations. That is the one way. But yes, I would like to other panelists if they have another methods that they can definitely
Okay, so other panel. So we have one more question. We can go to next question also. So the next question is on comfort posture. So how these criteria have been made? Example, red zone, yellow zone, and green zone. So I would ask our panelists to.
Yeah, this is actually according to the possible joint angles possible in the human body. For example, any joint in the body, the primary joints, they are uh, they are allowed for a certain amount of angles only. They can't go beyond that. So there is anthropometric limitations to the joints, each and every individual. So there's a algorithm built inside the software to know the angular variation and then assess that in terms of discomfort. So, for example, the shoulder joint, if I raise my hand up in the sky, upwards, then definitely that angle between the maybe neck joint and the shoulder joint will become uh, away from the become too much that it starts creating discomfort in the shoulder. So that's kind of algorithm built in the software itself. But the basics is the angular limitations in each joint. I hope that answers. Yeah.
Okay, thank you, Sushil sir. So our next question is, so even the vehicle integration team use some mannequins and do the ergonomics checks like ground position and many more. So will that be good enough, or so what are the benefits of this tool instead of using mannequin? Anyone from panel can answer.
Manasa ma'am.
Can you repeat the question, please?
Yes, ma'am. So the question is, vehicle integration team uses some mannequin and do the ergonomics checks like ground positionings and many more. So why
Okay.
the software is good instead of getting mannequins? Why this software is good for us? If you could answer this question.
When we actually use the software to understand the ground truth scenario, we were able to depict a very close, what do you say, a very close situation to the real life vehicle that you can build to it physically. I would say that in one, two trials of the physical part, we were able to understand how the software is trying to move it. I would say there's a very good match to the manikin and also to the real life Indian anthropometry which RAMSIS is offering as a part of sizing.
Okay. Okay, thank you, ma'am. So we have our last questions. So, ma'am, can you please tell in what all TVS models is the RAMSIS used?
RAMSIS is being used since the past 5 years. You could see wherever you could see a very good comfort in ergonomics. You could say that RAMSIS does did contribute to a good amount of improvisation in the comfort.
Okay,
And
sure.
Mansa ma'am, let me tell you that this is quite evidence in the recent bikes that TVS came up with, because I recently purchased last year TVS bike, and I'm really happy with that ergonomics myself, because I purchased TVS, one of the TVS bike last year. So it is quite evident
Right.
in that actually. Yeah.
That's very well answered. Just to pitch in, on the previous question, Sushil, you want to add any other points in addition to what Manza had mentioned, right, in terms of the why you would want to use Ramsys instead of a
Yeah.
manikin?
Yeah, Mansa ma'am really answered it quite excellently, but I just want to add some more to it. Like TVS, we have many car makers as also our customers who use Ramsys from decades actually, like Tata Motors, Maruti, also Mahindra and Mahindra. So we closely work with these ergonomics engineers in those companies, and the digital to physical correlation, what was the real question with the audience, is actually more than 90%. What we have come across with a lot of interactions with those ergonomic engineers in Tata Motors and Mahindra. So what Mansa said, like there's a realistic appearance of the human beings, digital mannequins, and it fit well on the vehicle geometries. So it's a one-to-one correlation is quite high. I think that is making Ramsys stand many miles away from the competition, hence it is globally used by more than 70% OEMs worldwide for their. I mean, everyone wants to save time, cost, and money, time, cost, and efforts. So Ramsys provide that leverage to you, where you can do any number of assessments quite early in the digital phase, so that you don't end up involving those much cost and time and efforts and design changes at the very last stages of the development, and thereby suffer the vehicle launch times, I think. Yeah, I think that was from my side, sir.
Okay, thank you, Sushil sir. So we are at the end of our session. So I would like to thank Miss Manasa Koda, Mr. Sushil Puraskar, and Mr. Satyam Pandey for delivering a very insightful webinar today. I am very confident it was very helpful for our audience today. I also would like to thank our audience for taking the time out and joining for this session. So I would, if you have any further queries related to this subject matters or any other requirements, you can always connect with us. So you can reach out to us at any time and we would be happy to address your queries. Please do keep an eye on our upcoming seminars and webinars. You can follow us on our social media platform for the same. So thank you everyone.
Yeah, here are our numbers, email IDs and numbers and names. You can reach out to us anytime for your any sort of queries, however big, however small, and we'll be able to guide you with the right analysis and right explanations. So looking forward to connect with you shortly and take up your queries around Ramsys application. Thank you very much.
Thank you.